talk is called Discrete Degrees, and there will be some discussion about physics and psychology in this evening, and less about God. God will appear a few times, but mostly I'm trying to establish an idea of what discrete degrees are, because as Swedenborg says, this is essential to understand the relation between spiritual, mental, and physical, and also between these things and the divine. So we want to look into, have some ideas of what discrete degrees are, and then I'll try to explain what I think discrete degrees are. So this is the second of the 4 evenings. And this evening will have 2 parts. The first part is to have an idea of substance, okay? Because a lot of people have different ideas about substance, and a lot of people have what I think of as incorrect ideas about substance. We'll discuss some of them as we go on. And we need to have a realistic idea for all kinds of things. So I'm going to propose a general idea of substance that can be used in slightly different ways, but for physical things, mental things, spiritual things. And it will be based on what I say here as the propensity or power or dispositions of things. So I'll explain why that's a useful way of looking at substances. And in particular, I want to introduce the idea of mental substance, because there's been a lot of debate in philosophy and literature and even among religious people about what mental substance is. And so I will discuss some ideas of those which I think are good and some which I think are not so good. So we'll come to that. And then once we have an idea of substance, then we can go on to talk about different levels or multiple degrees of substances, because we know we think we know that there are physical things, mental things, spiritual things, and they all coexist in some way. So that we want to have a sort of a scientific understanding of how these things could coexist, and not just have a world in which only physical things are. So it's like dimensions or planes. These are words that people use to describe mental and spiritual things, but I think a better understanding of dimensions and planes. And I'm going to provide examples from physics. I'm a physicist, so I like to have examples from physics. So there'll be a few examples which you may have a little fun trying to follow, but I'll try and explain them in a simple way such that with some basic ideas that I present, we can understand these physics things. And also some ideas from psychology. I want to show that there are, in particular, I want to show that there are discrete degrees within physics and within psychology. And if we can understand these, because we're already acquainted with those things, then this gives us a better idea of discrete degrees. And then from these examples, I want to phrase the idea, understanding of discrete degrees in a very general way. And the phrases, the words that I'm going to use for this general way of understanding discrete degrees are generation and selection. We have generation coming down and selection from below. And so these are the 2 ideas I want you to remember. And because then we can understand the general connections between multiple levels, between mental and physical things, between spiritual and mental things, or between the divine and spiritual things. We want to understand what those connections are, because only then will we have a proper scientific understanding of what these levels are and make predictions. And I have to say that both of these ideas about substance and about discrete degrees came from using Swedenborg. My early reading of Swedenborg led me to these particular understandings. So this was a use of religion and theistic ideas in trying to understand science. And so that's rather interesting, because some people say that theology doesn't have any use for science. But this is an example of how theology has been useful. And at some point, I'm going to come to what I think of as punchlines or thing to remember. So I'm going to use this little symbol here, a star and a circle, to point out things that may be useful for you to remember, specifically these things, because they'll be useful in debate when you're talking with people who want to understand what minds are, or when they say, whether people say minds are just the brain or whatever. So the first thing to talk about is substance. And now I'm going to start by I'm going to distinguish 3 things: substance, form, and dynamics. And some of these things are stressed in Swedenborg and some from physics. So, but I want to, this involves, the next couple of slides involve some sort of systematic thinking about what things can really exist. Because I claim there are three categories of terms in science, or also in theology for that matter. The first thing is formal terms, the forms of things, the structure of things, the properties of things, whatever exists now. If you were to look at something, you would see its form. If I look at the chair, I see the shape of a chair. I can't tell what it's made of, I can't tell what it does, but I can tell that it's the shape of a chair. So this is like the manifestation or the existere, as Swedenborg puts it. This is what's manifest and immediately obvious. That's the first thing we need to know about something. The second thing is what exists. If I look at the chair, I want to know what it's made out of. What's the substance of this chair? And then the question is how do we tell what the substance is? That's the question which I want to answer. And the third thing that we need to know about a chair or a person or anything is its dynamical properties. This is what science in particular is interested in. It wants to make predictions how things would behave, what would happen in new situations or hypothetical conditions. So an engineer designing a new building might put material in a configuration that it's never been used before, but if he knows the dynamical properties of his materials, he can predict how the bridge or the building will stay up by using science. And if you only knew the shape of things and what things existed, you wouldn't be able to predict that. So any scientific explanation requires also these dynamical things. So only by dynamics can we make predictions. So these three things, these three categories, I'm going to produce some more examples from science. So when we say form or existence, we have this long list of things here: shape, numbers, functions, fields, oscillations, vibrations, waves. The font is a little small there. Or numbers, anything to do with mathematics is in that section, in this category of form. These are the things that's manifest to start with. And mathematics can tell you immediately what's happening, and but it only tells you what you can see, what the shape is that's there. Are you okay there, Gloria?
Yes.
Yes? Okay. And then the second category that I listed was existence. What exists? And we can see here words like particle, material, substance, matter, corpuscle, or fluids, or reality. All of these things talk about what exists. But the trouble is that if you just know what exists without knowing how it behaves, you don't really have much to go on. So this is the question of ontology. Ontology is the science, so to speak, of what exists. And the third category is the dynamical category. And this is the question of physics or dynamics. Psychology is also interested in how people behave. And you can see where I'm coming to in a minute. We need all three of these categories, because if you just have form, it doesn't tell you what exists and it doesn't tell you how it behaves. If you just have form in existence, it says that there's a shape here that exists, material shape that exists, but it doesn't tell you how it behaves. And if you just have properties, so you just have dynamics, you want them to exist in some way. In other words, you can't just have forces by themselves without anything having the forces, without something existing.
You mean form in the sense of an ideal cube or something?
Well, not just an ideal cube, but an actual cube. It could be some funny, weird shape. It could be an irregular shape, but it has a shape. The chair has a shape. It's not a cube. It's not a rectangle. It's some interesting shape. And computers are very good for describing form.
The shape is separate from the actual substance.
Indeed. Normally we think of the substance has the form, or there's a substance in a form. See, computers, for example, are good at shapes, and they're good at describing changes, but there's no substance in computers. There's no existence. So you can see that virtual worlds are form with moving forms, so they have dynamics and they have form, but they don't have the substance in the middle. So you need all three of these in order to have a proper understanding of physics and a proper understanding, I will argue, of psychology and even a proper understanding of theology. So I'm going to say that we need to have an idea of substance. But the trouble is that it's difficult to form an idea of substance. So what I'm going to do is to use dynamics, use the dynamical properties of something to define what its substance is. Now, this may seem obvious to some people, but it's not traditionally done in science by people who think that they understand. It's done in practice in science, but people who try and understand science don't like this idea so much. And this idea that I'm going to put here is that the substance of thing is its propensity to do something. In other words, if we go back to this previous page, oops, where are we? If we have all of these three categories here, we're going to use all of these ideas to derive what existence is. In other words, I'm going to say that something just comes from what it can do. And this may seem inadequate, but in fact, it's used a lot by lots of people. And I'm going to show how it's used. When we talk about an electromagnetic force field, a radio wave, for example, is an electromagnetic force field. It carries energy from the transmitter to the receiver. The electromagnetism describes the dynamical properties, and the field, whatever shape it has, radiating away, is the form, which is described by mathematics. And similarly, we have a potential energy field. We think of the gravitational field of the sun in which the Earth rotates and keeps the Earth in position. This is a gravitational potential energy, and this is a field. And so energy is like the dynamical properties, but we're going to say that things are made out of energy. Now, this is rather obvious now, in fact, but it took a long time for this to be acceptable, because now we're so used to Einstein saying that matter is a form of energy. This is commonly accepted now, but 100 years ago, it was very difficult to understand this E equals mc squared. This is the relation between mass and energy. So, but by now, we accept that matter is a particular form, it's a particular kind of energy that is designed to behave in some ways. So an electron has electric charge, and it has mass, and it has magnetic field. And now we come to quantum mechanics, because quantum mechanics is what we normally think of as the best way of understanding physics these days. This is my day job, is to do quantum mechanics. So I'm going to show some ideas which I have from Swedenborg, which will help me to understand what quantum mechanics is, and I'm trying to understand that a bit better, because we'll show in a bit more detail later. But in quantum mechanics, we have a wave function, an oscillatory wave function that propagates out, and it produces random events. And so the question is, how you understand that in a realistic and scientific way? And so I'm going to say that the quantum wave function is a propensity field. It's a field of propensity. It's a propensity to interact, to make a measurement or a selection or to localization. It's a propensity to choose an actual outcome. And this is in the same way as we have fields of substance. Now, you have to remember that propensities are still present even if they're not acting. So the gravitational field of the sun is still present even if there's no Earth going around it. So in other words, the gravitational field persists through time, and that makes it like the energy of the gravitational field is like something that's existing. It carries energy. The gravitational field carries energy. And I'm going to now argue that we don't need anything more to existence than the set of all the propensities for what it can do. This is called, in philosophy, the Eliatic Principle. A thing is known by what it does. This is the same principle we're using here. Now, it may seem that I'm giving away too much when I say the thing is only known by what it does. I'm saying there's no such thing as the hidden nature of an electron that produces all its properties. I'm saying that the electric charge and the magnetic effects and the mass, the gravitational mass of an electron, just what an electron is. And the reason is that this is also useful in theology. So, now first of all admit that I said this is a new idea, but it's actually Aristotle, even Newton had some ideas like this. So we'll see in a bit more what Aristotle was up to. And so by means of this idea of a substance that's composed of all its propensities for action, we can also look at mental substances, because I claim that this works for minds. Because traditionally, we haven't understood what minds are. We don't know what a mind is. We think of it as something we know not what. You know what I mean? Descartes said it was rationality. Other people say it's consciousness. Other people say it's something strange. But what is it? But now I'm going to take a rather simple idea of what minds are by saying that mental substances, those things of which minds are made, are just the propensity for mental actions. In other words, their loves and desires are the substance of which minds are made out of. In other words, love is the substance. And another word for propensity is dispositions. And Gilbert Ryle, 1949, wrote a long book. He thought he was writing a materialist book in which he said, minds are nothing but the dispositions to act. But if we take dispositions as referring to real substances, then I agree with him that minds are dispositions. He thought they were physical dispositions, but now I say you can form an idea of mental dispositions.
When you say minds, is that to be understood as thoughts?
For example, we'll come to what thoughts are in relation to these loves and desires. And in fact, one of the encouraging features about this is that Swedenborg also says, as he said, divine love and wisdom are themselves substance and form. In other words, love is like a substance that makes things. And so I think this principle of love being a substance, or the substance of minds being love and desire, is a very general thing which can be very useful because it explains exactly what minds are. They're made out of desires and loves. And we know we have some acquaintance with our desires and loves. And so therefore, we begin to have some basic ideas of what minds are. And so the question then is, what are they loves and desires for? So there's lots of different loves and different desires we could look into. But once we have the basic idea that physical things are propensities in a certain form, and also mental things are propensities in a certain form, mental propensities, then we have a general principle, a general understanding of what minds are, which is very useful. And as I said at the beginning, the idea came from reading Swedenborg first. He said that love is the substance of man. I'm not sure he said exactly that, but this is what I remember.
Would you call intention a mental propensity?
Yes, it's one of the mental propensities. There's a lot of thought component to that, which is Jim's question. But an intention has a specific idea in mind, whereas a love doesn't always have something in mind. So
love prior to its descending into thought could be called mental energy. I mean, I've experienced mental energy before it descends into thought.
Yes, we'll discuss later the difference between love and energy. So if we look at, if we use this idea of mental minds being composed of love as a substance, then we can look at various other ideas that have been proposed historically, and we can get some idea how good they are. So I'm going to list some what I call bad ideas about mental substance. Thomas Aquinas, for example, said that the forms of things were minds, were the substance, were mental. So if we go back to our list of three things, form, existence, and dynamics, only the first column, he would say, if it was immaterial, would be what a mind was. But then that doesn't give us any substance, it doesn't give us any dynamics, so that's clearly inadequate. René Descartes said that mind, res cogitans, a mind was a thinking substance. And that's beginning to be a bit better, because thinking is one of the motivations which goes on in our mind. But I think loves and desires are a better description of this underlying structure of minds. And thinking to answer Jim's question, is one of the intermediate products of mental action before it becomes action. And then, more recently, matter has been taken to be the substance of mind. They say our minds are just brains. And this is what's been adopted by the materialists and the physicalists. But that's the wrong, matter is a propensity, because everything that exists is a propensity in some form, but it's the wrong kind of propensity. It's a propensity for physical actions, not for mental actions. So you still have to work out what the desires and loves and propensities are for. What are they trying to do, so to speak? David Bohm had an idea that minds are related to information. But this also was a problem because information is still the first of those three columns. It's just the form and not the existence or the dynamics. He realized that was a problem, so he talked about active information. But active information still doesn't say what exists, and it doesn't tell you what would happen. It just says that something is happening. But we still have minds even when we're not doing things, and even when we're not thinking, so to speak. Our love is still present, even then. Other people I mentioned last week had this idea of quantum vacuum as a hidden layer behind the physical, which is present all the time and is responsible for the production. And they think of this as sort of like a spiritual dimension. But the trouble is, quantum vacuum is from quantum mechanics, and that's physics. It's the wrong kind of propensity involved when it comes to doing things. And finally, a popular idea of consciousness is consciousness. We think of God as pure consciousness, or they think of, when people want to know about minds, I have my consciousness. This is who I am a consciousness. But then the question is, what does consciousness do? And this question of what consciousness does has been bothering philosophers for a long time, starting with David Chalmers, who said that, if consciousness doesn't seem to be doing anything, there's no dynamical properties that follow from consciousness. It exists in some sense because we can tell if there is or isn't consciousness, but there's no dynamical properties. So I will come back to consciousness later, because clearly consciousness is an important part of minds, but I'm going to say that consciousness is the mode of operation of love rather than the substance that things are made out of. So the question is, by now, having this idea of substances made out of propensities in some form, you should be able to take these ideas. If someone presents you an idea of minds as made out of one of these things, you should be able to understand why these are not satisfactory ideas of minds, or what minds are made out of. Now, I've been talking about minds, but I'm going to come back to quantum physics because I like quantum physics. And in quantum physics, I want to show here. Now, some of you will have had an understanding from Swedenborg about love being a substance. So I'm now going to try and get you to use those ideas to understand quantum physics, which is not the usual way of teaching, but it might be useful in your case. So in quantum physics, there are random events. That's the feature. Radioactive decay is a random process that spontaneously goes at random. And this radioactive decay comes from a wave function which is spread out in space. And furthermore, so here's a little picture of a wave function. And furthermore, this wave function comes from a solution of what's called Schrodinger Equation, which is an equation about energy. This energy is kinetic energy plus potential energy, if you remember. And so Schrodinger Equation says that the total of kinetic energy and potential energy produces a time change of the wave function. That's just a sort of verbal summary of what this basic equation in quantum physics says. And so if we come to the way we understand now, we're going to say that this wave function is a form of propensity. The propensity is for probabilistic events. So whenever we talk about desire or love or propensity, we have to say what kind of love or what kind of desire, what kind of propensity. We have to say what it's for. So in quantum physics, propensities are propensities for probabilistic events or selections or choices. The electron is going to one way or another. And And now the principle that I just had was that this propensity is the substance of a quantum object. So this little picture here shows a quantum object that's spread out in space. So there's no specific very small particle. There's no point particles in quantum physics. There's only waves of various sizes. Sometimes they're small, sometimes they're big. But in each case, we have a wave and a wave of propensity. Normal physicists say it's a probability wave, a wave of probability, or probability amplitude. But a probability is a number, and an amplitude is a number, and a wave is describing a number. So to say something is a probability amplitude is to only give something from the first of these three columns. It's only to give the form or the shape or the mathematics of it. It doesn't say what exists or what happens. So what I'm saying here is that the propensity is the substance and the wave is the form. And this is an understanding of whenever we look at things in the future, I want to argue, we should look at what the substance is, which is its propensities, what it does, and we should also look at the form it has, which is how it appears. So if we go back to the example of a chair here, we can see the form by looking at it, and the substance of the chair is defined by all of the ways in which the parts of the chair will interact, its propensities for interaction. And I'm claiming there's no other hidden substance behind there apart from the parts and their propensities. And the task of science is to understand what the parts are and what their propensities are in general, whether they're physical or mental, whatever they might be. But if we go back to the top of this slide here, we said that I talked about a wave function spread out in space, and it comes from a wave function about energy. This is interesting because it means there's a bit more detail about discrete degrees going on here. There are what I say are two stages of operation in quantum physics. So we have actual outcomes, which are where the electron hits a particular photographic plate, a measurement. And then we have the wave function, which produces that according to what's called Born's probability rule. And then we have, okay, that's Born's probability rule. And the actual outcomes are selections. And then we have this active energy, this sum of potential and kinetic energy, produces the wave function, and then the wave function produces the outcome. So this is, immediately we see that there are more than two discrete degrees. Here there are three discrete degrees, and we'll see later on we'll come to many discrete degrees. So I'm saying that even in simple physics, there are many discrete degrees, and this helps us a lot for those who are interested in these things to understand what discrete degrees are in Swedenborg, because Swedenborg also has many discrete degrees. And furthermore, if you look at, I haven't said so here, but the next actual outcome depends on the propensity wave, and the propensity wave depends on the previous outcome. So there are boundary conditions in the production there are selection rules, and we'll see the structure of this in more detail later. So I think this is just a summary of, yes. So what I'm saying here is that energy and propensity are two different kinds of substance. There are two different kinds of substance in this case. There's energy, which we think of as a substance, E equals mc squared, it's like mass, matter, but there's also this propensity for producing things, and that's produced by the energy. So in quantum physics, there are two stages of operation. And for those of you who want to think about this from a Swedenborgic point of view, this is like sort of spiritual and natural and then the final effect, okay? One produces the second and the second produces the third. This is the sort of a sequence there. But in this case, this energy and this propensity, neither of them are mental propensities. Now, if you go back historically, James Jeans said that when he saw quantum mechanics, he said that the wave function looks like the operation of a mind rather than matter. And many people have taken the existence of a wave function spread out in space as indicating something mental. I agree that it's one discrete degree above these actual effects, but it's still a physical degree. We'll see later what mental degrees are. So here we have discrete degrees in physics, And furthermore, other people have said that energy is the hidden spiritual nature of everything. But here, energy is still described by quantum physics. We'll see later that there are many more degrees than that. And that's where the spiritual and mental things are. Jim?
When you say in number 4, 2 kinds,
yes.
The way I'm looking at your diagram, I'm seeing a causal pattern left to right.
Yes.
So I'm wondering if that's 2 stages.
Well, you can call it 3 discrete degrees or 2 stages of operation.
Yeah.
We have to think of our terminology.
But I mean, there's a causality.
There is.
There, so that they're connected across the discrete degrees.
Yes. So the discrete degrees are not independent of each other.
They are 2 kinds, and there are also stages when they're...
They operate, yes. Energy is continually producing the propensity wave, and then the propensity wave produces actual outcomes occasionally. So there's different kinds of structure involved in this.
Aren't all these all on the level of matter, though?
Yes, exactly. They're still in physics.
They're all the same degree.
Oh no, but they're sub-degrees of the physical, okay? But so far I haven't...
They're not really discrete if they're all on a continuum.
No, but they're not a continuum because these are qualitatively different. Energy is qualitatively different from propensity for probabilistic events, and probabilistic events are qualitatively different from waves, okay? So that you've got to think of many possible discrete degrees, okay? They're still discrete degrees, but they're sub-degrees or sub-sub-degrees, or will come in the next lecture. You'll get an idea of what's going on here if you're here, okay? So this has been my understanding that I've reached of quantum physics using ideas from Swedenborg, okay? So it's an interesting, this is one of my favorite hobbies. I wrote a paper about this 20 or 30 years ago, 1988, in which I talked about these propensities. I called them real dispositions. And if you look at that, you can distinguish some bad ideas. Again, I'm going to list some bad ideas about quantum mechanics, which you may have heard about. My colleagues have this, what they informally call the shut up and calculate philosophy. In other words, it's just used for predictions, and if it predicts the right thing, then that's good, okay? But this doesn't tell you anything about what exists in the quantum world. It doesn't tell you what electrons are made out of, or atoms, or brains, or anything. So not many people, they do this during the day, but it's not exactly a lifetime way of looking at things. Niels Bohr had a rather different idea of what existed. He thinks just the final thing on the end, the actual outcomes, were real, and the 2 previous things were just ways of predicting the actual outcome. So at least he had something existing. He had what's called classical observations, or actual measurements. He had them existing, but not the 2 earlier ones. He didn't attribute any reality to the wave function or to the energy involved. So that doesn't tell us what propensity or substance is. It doesn't tell us what exists between measurements, for example. Only the measurements are real, according to him. Another one you all have heard about is the idea of a splitting universe. Every time you have 2 options for making a measurement that are both possible, then the universe splits into 2 copies. So this has the first 2 stages. Actually, at the bottom here, I have these 3 stages. According to parallel universes, we have the Hamiltonian producing the wave function, but the wave function keeps splitting forever and ever. There's no selection involved. So it only has the first 2 and not the third one. So that's, nothing actually happens in the parallel universes theory.
This is Nicholas Everett?
Yes,
I don't know. Well, keep going.
Yes.
I don't understand what he's saying.
No. I'm not saying that you have to understand it at the moment. I'm just saying that if you look into it, you'll discover it's not a very good idea. And many physicists have come to that same opinion. And just for completeness, well, one of them. David Bohm had an idea that there was a hidden classical particles that were governed by the wave function. And I list the difficulty of that view is that this middle wave functions are not really real in any sense. They're just calculational devices for guiding these hidden particles. It's also called the pilot wave theory. De Broglie postulated something like that. So this is an idea in which there are energy and there are actual outcomes, but there's no wave function in the middle. So I'm saying that a proper understanding has all three of these components and doesn't try and neglect any one of them, because if you neglect any one of them, you get one of these I call bad ideas about quantum physics. But I claim that we know from Swedenborg that things occur in trines or triplets, so that we should expect this pattern of A to B to C occurring. And then finally, Eugene Wigner suggested there's selection by consciousness. I say, first of all, that these propensities I have are propensities for selections. And so therefore, they're not mental propensities. But it's still, then I leave it open, but maybe when. Henry Stapp here at Berkeley suggests that consciousness decides when the selections occur, and that's still possible. But it's certainly not quantum waves are made out of consciousness. Okay, so that's the first half of my talk for this evening. A basic idea of substance, which can be used for physics and for mental things, and maybe even for spiritual things. Yes, Steve?
For clarity of understanding them.
Yes?
When I think of a chair, I would say the propensity of a chair is to provide sitting.
That's one of its propensities, which depends on it being strong enough, doesn't it?
The substance of a chair
is the set of, among all the other things that could happen.
Okay, sort of the probability.
Yeah, it can be X-rayed as well. It reflects X-rays in a certain direction if you were to do that. All the possible experiments you could do on a chair are determined by its propensities. Not just a few propensities, but all of them together.
Okay. So I'm used to this idea they talk about probability. Propensity isn't exactly the same as probability.
No, propensity is a disposition or power which has probabilistic effects. Okay. That's the definition of a propensity. So it's a power or disposition or desire which produces results probabilistically rather than surefire, so to speak. That's something reliable that just had always the same effect. So we come to the second half, which is about multiple degrees, because I want to then use some of the ideas so far, and I want to, and later, next week, I want to show how you can use these ideas to show how God, for example, and creation are separate but interrelated. So this is the challenge. And all of these things, discrete degrees, are separate, distinct, distinguishable, but they're connected, causally connected together. So the challenge is to have a sort of a scientific way of understanding how that works. And as I said, this idea comes from Swedenborg. But I've used this idea to go back to physics and trying to understand basic physics. Okay. And just as a flavor of how this can be used, I'm going to discuss different ways in which mind and matter can be related. We have mind and matter, and the first view, okay, that's supposed to be a shaded. We can have matter causes mind, which is sort of the physicalist view. We can have mind causes matter, which is like a new age or we create our own reality kind of view. Then we have the idea of in which mind and matter are in parallel, but they don't cause each other directly. This comes from Leibniz's pre-established harmony, and it's still used in Swedenborgian circles when they think of things related by correspondences. But I want to advocate a view in which mind and matter interact. Descartes had them interacting. So there are causes in both directions, but not of the same kind. Okay? So if you look at the picture there are arrows going in each direction, but not the same kind of arrow. There's a causation from mind towards matter, but there's some kind of arrow going back. It's not the same kind of arrow, but it is an arrow. There are effects going in the backward direction.
So you understand that when Swedenborg talks about this idea of mind and matter interacting,
yeah.
He would say that on each distinct level there's an interaction on a horizontal.
Yes.
But that the levels are, I don't want to use a hierarchy, they're kind of like going from inward to outward.
Yeah, but they
still don't go backwards. They only interact on the horizontal.
I want to show that there must be some backward connection of some kind.
You're saying across the distinct levels.
Across the levels, there has to be some causal connection. If you say they don't interact, then you're going back to this number 3 here, in which mind and matter are like parallels that just happen to behave in agreement with each other. So we need to understand how Swedenborg can be correct about causation only going from God down towards nature, but still there's some effect back from matter. So we'll come to that, okay? So in Swedenborg, there are many discrete degrees, so we want to understand that. Now I'm going to have a couple of little simple physics experiments. Galileo had an experiment in which a ball was rolling down an inclined plane. So this is someone dressed up as Galileo in a museum in Italy. And we think of the gravitational force acting on this ball coming down the plane. So we're going to think of it just as a fixed force. And if we want to know what the effect of this gravitational force is on the object, we use Newton's second law, which is force F equals ma, force is mass times acceleration. And we're going to use it in this other way around. We're going to say that acceleration is the force divided by the mass. In other words, acceleration occurs as a result of the force acting on the mass. This is perfectly standard Newtonian physics. This is the way Newton interpreted Galileo's experiment. So I now want to say that force is a disposition, because it's a power or propensity, force is a disposition to accelerate a mass if the mass is present. I mean, it might seem rather obvious, but forces don't accelerate if there's no mass. So the force can be there, but the acceleration only occurs if there's a certain circumstance or occasion of the mass being present to be accelerated. And so I want to summarize this by saying that in the presence of an inertial mass, the presence of inertial mass is the occasion for motion. So the ball being present means that the force can act on it and produce the effect. The force can't produce the effect directly without the mass being present. Forces don't produce acceleration if there's no particle to be accelerated. So you have to set up the experiment. There has to be something physical there for the force to act on. And so the principal cause, I'm going to say, is the force, but the occasional cause is the presence of the particle. So the occasional cause is the condition that has to be satisfied for the principal cause to operate. And now we can do this again. If we think of now an inclined plane with various slopes, you can think of going up and down a hill on a bicycle. It's sloping up on the left and sloping down on the right. And the force is going to vary according to the slope. If you've been on a bicycle, you know this very well. And the gravitational energy produces the force. As you go up the hill, you have to put in energy, which gets converted to gravitational energy. And at the top, you've got all the maximum gravitational energy. And when you come down, changes in the gravitational potential produce the force. So this is rather simple physics, Newtonian physics, but the force that we had on the previous transparency is produced by the gravitational energy. And it's produced according to the slope. In other words, the variation in the local conditions of the action. So we have a similar pattern to what we had in quantum mechanics. We have these 3 discrete degrees, or 2 stages of operation. On the left, we have the potential energy, which could be gravitational here. Newton's law of gravity tells us how that produces the force. Forces add, and they do things there. And Newton's second law tells us how the force produces the acceleration. So this is simple, so to speak, high school physics about how things behave in a gravitational field and how things are accelerated by forces. But even here, I argue, we have these discrete degrees, or discrete sub-degrees, or whatever they are, that should remind us of Swedenborg. They should remind us of how Swedenborg has discrete degrees, because it's the same process going on. So again, we see 2 stages for the operation of propensities. That's a physics example of 3 discrete degrees with 2 stages of operation. Now I'm going to show an example from psychology, a rather simple example. We're going to talk about the deliberate control of hand movements, okay? And psychologists have investigated this. They have this complicated picture here, which probably the font is a bit small to read, but it starts off by, you first of all have an intention, one of your intentions to act. It's remote from the hand itself, so it's called distal or D. And then there's the monitoring. When I move my hand, I look at it to make sure it's going in the right place. So if I'm trying to find something that's moving. So this is proximal control of the hand, so detailed monitoring of the motion of the hand. And then this detailed monitoring of the hand then guides the operation of the muscles. So we have what the psychologists call cascading intentions. The initial intention produces a monitoring in detail, and then the monitoring in detail controls the actual operations of the muscles, and then it produces the movement. So we actually have 3 stages or 4 discrete degrees, because we have the initial intention, the proximal control, the motor control, and then the actual outcome. So that I'm arguing that this is a simple example from psychology of the operation of discrete degrees. And those people with the Swedenborg background can recognize some of the intention and understanding and action there in that set of 3 discrete degrees. Yes, Steve?
You would say how there's a communication coming back?
Yes.
So would the example of the correction be an example of the
yes.
bottom?
So if this picture here has some little arrows going back up on the right-hand side, you have to monitor your action. So vision, okay. To take a simple example from Swedenborg, if our mind looks at nature, looks at a physical thing, there has to be input from the physical thing back into the mind through our eyes. So there has to be some way of getting feedback from the physical degree to the mental degree. Otherwise, when we look at things, we will never notice anything because our mind couldn't be affected by the physical. So it's clear there has to be some feedback in both directions. That should be obvious, except some people forget it. So what I wanted to say now is that, oops.
So if somebody is blind, how do they?
They still have a proprietary sense of motion. They have a very delicate hearing and sense of touch, which enables them to control things. They can write pencils, they can do, other senses become more acute normally in that situation. I want to say that these examples, I've given now 4 examples of discrete degrees from, shall we say, normal science. We have the quantum mechanics, energy, propensity, actual selection, classical physics, potential energy, forces, acceleration, psychology of motor control. These are all examples of discrete degrees that are known by science already. And if we were to get a better understanding of Swedenborgian discrete degrees, then we should pay attention to what these discretes are, because we're going to learn something. And that's what I say. So we're not making a giant leap into Swedenborgian discrete degrees. We're going to learn from what science knows already. It's just a question of recognizing that these are discrete degrees, because it's not obvious that they are discrete degrees. So as I near the end, I will give a couple of slides of the sort of general principles. I'm going to summarize what I've learned from these examples and summarize them in a general way. I'm going to talk about A and B. I'm going to first of all talk about 2 discrete degrees with 1 stage of operation, which is that if we have just 2 discrete degrees, all of the previous examples were more complicated, but this is a simple example. So A generates B. A is up and it generates B. But the point is, in all those examples, which new B was generated by A, the selection of the new B is determined by the old B, okay? So if we go back to those examples let's see, which one should we choose? the ball rolling down the plane. The acceleration depends on the mass being present and where it's present and so on. Or when we go to quantum mechanics, the actual selection at a later time depends on what previous actual selections there were. And in quantum mechanics also, the wave function at a later time depends on what the initial wave function is. So there's a dependence, and I'm going to draw a picture of this to illustrate. And if you want to imagine it in your mind, you can think of A being our mind and B as physical effects. Those are B's there. Very pale. Or you can think of God and the world if you want to have some dramatic example. So in 2 degrees, we have A generates the successive events in the 2nd degree, but the choice of which events are selected depends on the previous B's. So these black arrows are selection which guide the operation of these generation events. So this is, I want to claim, is the general way that Swedenborgian discrete degrees operate. There's always the twin processes of generation power coming down, but also the previous existence at the lower degree selects in which ways this power can operate.
Are you talking about Markov chains or something like that?
You could easily generate Markov chains like this, I agree. But I'm not saying it's random or not. I'm just saying that there is the better idea is causal networks. I don't know, but you can describe them using Markov chains. It's rather similar. And there are these twin processes of generation and selection, which is what I want you to remember for how discrete degrees operate. There are both generation and selection. If you just have generation, then the outer layer is produced, but it never has any effect on what happens in the future. It's sort of like just an outside layer which is produced and then blown away. And if A was our mind and B was the physical nature, then we would never be able to observe what happened in the physical world because we would never get feedback from the physical world. So there has to be both. So there are processes going in both directions, but not the same kind of process. And I claim that these twin processes of generation and selection you can see them clearly in those examples that I gave earlier. In all of those examples, if you looked into how it operates according to science, there were both generation processes and selection processes operating. And so I say that it would make sense also from Swedenborg's point of view that there are both generation and selection. However, if you just take these two layers like this, okay, generation is from the higher degree, it's the principal cause, and selection is from the lower degree, it's called occasional cause. And the general rule is the principal cause operates according to the occasional cause. That's sort of the influx, the law of influx that Swedenborg has.
So, it'd be like gravity would be the generation.
Yes.
And the slope of the angle would be the selection.
Yes, for example. So the effect of gravity depends on the slope of the object that is accelerated. We know that. And if the slope is flat, gravity doesn't have any effect. But if it's steep, it has a big effect. So the slope is not doing anything, but it's conditioning what the generative cause does. So now, if you just had these 2 degrees like that, then we have pure. If A was God and B was the world, we would have what's called pure occasionalism. Nicholas Malebranche, at the same time as Newton, had this what I call simplistic view in an attempt to understand the relation between God and the world. The trouble with this simplistic view is that every action is caused directly by God, okay? Every fish jumping out of the ocean is God jumping out of the ocean. Every action, every evil action, every good action we do is God acting immediately. Now, some people might be happy with that, but I don't think reality is that simple, because we saw even already that there are more than 2 degrees. So let's consider 3 discrete degrees. And we think of, if you want to picture it in your mind, as A is God producing mental operations which produce effects. Okay? So A generates the further existence of B, and B generates the further existence of C. But each new B is generated by the previous B, so we have a complicated network of generation coming down and selection sort of going sideways or very slightly up, so to speak, if you want to use a spatial metaphor for what's going on here. So, and then the time goes to the right. And so I summarize it by saying all generation is down and all selection is from below. And I claim that this is actually, even this triplet of discrete degrees gives a better understanding. It's no longer a pure occasionalism, okay? It's no longer God acting directly in the physical world. It's acting by means of an internal degree. And it's no longer a pure occasionalism because degree B, the middle degree, these things really exist. They are propensities for doing things, producing C's, and therefore they really exist as substances. The middle degree is a substance, but it's continually being produced by A, and it's continually producing the lower degree. And we say that B, the middle degree, filters the initial propensities of A to select and affect what the result is. And most interestingly, the first degree never changes. Okay, so that makes sense from the God point of view. God is the A at the top here that produces effects all the time, but never changes or never necessarily changes. So that point of view makes sense. And I'm going to add here that there's still questions of the relative importance of generation and selection. If generation was dominant and selection was minimal, then you have sort of this new age idea of we create our own reality. But if generation was very weak and selection was dominant, then we would have a materialistic view in which the lower degree only depends on the previous lower degree and nothing of influx from above. So this is a general framework in which you can discuss the relative importance of generation and selection. So the detailed science consists of seeing exactly what generation occurs and what selection occurs and how much freedom and room to maneuver there is at each stage. That's where the crunch is. Okay. So let's now begin to wind up. I've repeated this pattern of the 3 discrete degrees here. And in quantum physics, we have these energy, propensity, outcomes. And I can summarize it by saying that there's a principle of energy, there's a distribution of form, and then a final effect. And this is, I can claim, just like in the mind. In the mind, we have a desire, which is the initial motivation just in the mind. We have thinking, which is the intermediate step. Our desire thinks what to do, and then it acts. So I'm saying that desire is like substance and thinking is like form. And this also agrees with Swedenborg. And so what I'm saying, there are similar processes of generation and selection in the minds and in nature. So the same general philosophical principles are involved in both the discrete degrees in mind and the discrete degrees in nature. And each degree, I haven't actually justified this, each degree has its own being because it's its own substance. It has its own space because it has its own interaction propensities, and each is a substance, therefore it exists.
Do you mind if I ask you to, keeping this in mind, the 3 degrees, and go back to Malebranche's 2 degrees.
Yeah.
Malebranche was one of the philosophers Swedenborg read the most of. And is Malebranche of his 2 degrees, he's collapsing A and B for the energy dispositions?
Yes. Well, I mean, you can have a disposition which just produces effects immediately. Imagine the love of God immediately producing physical effects without thinking, so to speak, or without planning, without consideration before acting. You could conceive of the world being made that way.
His occasionalism was that the phenomena gave God the occasion for acting?
Yes.
Or vice versa? I guess that's...
No, phenomena gave God the occasion. So my deciding to move my hand was just the occasion for God moving my hand. So I'm using the word occasion in the same sense as that he used occasion. It's the same occasionalism.
Right, so he didn't actually see any causal relationship.
No, not if you look at his view.
Like Leibniz's in a way.
Yes.
These two.
No, God, Malebranche had God's power acting all the time,
Okay.
according to the occasion of our actions, this influencing God. So God looked at what we decide to do, if we, in fact, we could decide to do. That's another question, and then acting.
Okay.
So I think we're coming to an end here. I just want to end by saying that there's a couple more slides. One of them is to show that quantum mechanics is more complicated than I've showed. I showed 3 discrete degrees, but just to give you a flavor for what might happen, there are actually 2 sets of triplets. So this is the set that I showed earlier of energy, propensity wave, and actual effects. This is, I call, the actual degree. But if quantum field theory says that the energy has kinetic energy and potential energy, and quantum field theory says that kinetic energy comes from mass, which is constructed by virtual processes acting behind the scenes. And similarly, potential energy is not just fixed, but it comes from the exchange of photons or gluons. So that means that there's actually a similar layer, a similar set of triplet of degrees called the virtual degree. So there's the virtual principle that governs these, and there's virtual quantum fields and virtual events. And the virtual events act to produce what goes into the energy operator here. So I'm not going to explain this in detail. All I want to say is that these discrete degrees are a useful way of understanding the more complicated structure that physics is already discovering about what happens in nature. So this is sort of what's called ordinary quantum mechanics, this triplet. But these 3 above here is quantum field theory, which was invented at the end of the Second World War, and it's become the dominant way of looking at things. And it just gives you an idea of how things may yet become more complicated than we've shown so far. And so you have to have a rather general idea of degrees and discrete degrees. So what's important is the functional relation between different things, which I say should be thought of as discrete degrees, these generation and selection. So there are more complex structures of discrete degrees should be expected. And I end now by giving a little preview of next week's talk, which is about trying to understand theism. So I want to show that we need to form good concepts of God, which are not metaphorical or hidden from science. Last week I gave you a preview of what these principles were, but now it comes to drawing out the consequences of those principles. And in particular, we want to see how we derive our life from God. And because God is love and being and wisdom itself, but we love, we think we have some wisdom, we do things and some life. So the question is, how does our life derive from God's life itself? And I say, by generation and selection. These are the 2 principles which we need, which produce the discrete degrees that many people have talked about over the centuries. So I'm saying discrete degrees are the product of the principles of generation and selection acting in stages. And so we'll discuss some details about that in the next talk next week. Thank you.